In this video, we're going to talk about Pythagorean theorem and its converse. So that's going to be something new. The first half will be a little bit of review, and then the second half will be some new material. So first, your Pythagorean theorem, you can use in a right triangle. It has to be a right triangle, and it's to find a missing side in a right triangle. We use it by squaring the length of the hypotenuse and making that equal to the sum of the other two sides squared and added together. So remember, in a right triangle, the hypotenuse is the side that's across from the right angle. That's always the longest side. And then there are two legs in a right triangle. So one could be shorter, one could be longer, but they're still considered the legs in the triangle. So our equation is a squared plus b squared equals c squared. So remember, your c squared has to be the hypotenuse. The a and the b, really, they can mix around. It could be the smaller or the shorter leg. With the longer leg, that doesn't matter as much. So in this first question, we're going to practice. We can see that the 5 right here is the hypotenuse, so that has to be 5 squared at the end of the equation. But the x squared and the 3 squared could be mixed up. It doesn't matter which order. So when we solve this, we need to square both of them, which gives us a 9 and then a 25. To solve this, we need to subtract 9 from both sides. We get x squared equals 16. To undo the squared, we need to take the square root of both sides, which then cancels out the squared, so we end up with just x equals, and then our 4. So in our problem up here, we know that the x is equal to 4. So now I'd like you to try working out this question right here. So remember, the hypotenuse always has to be the c squared. So go ahead and push pause, and when you're ready to check your answer after you've worked it out, go ahead and push play. Alright, so like I said, the hypotenuse has to be the c, but then our a and our b could be mixed up between the other two. So when you solve it, this is what it should look like. So you end up with a 36 plus 64. On the same side, so you just add like terms together, so we get a 100. And this equals your x squared. Remember, to undo that, we have to take the square root. So that undoes x squared, so we end up with x equals 10. So your hypotenuse in this problem equals 10. For the next one, I would like you to try this one again on your own. This is just more of a word problem, but the same setup. This is going to be similar to the one that I tried with you. So remember, your hypotenuse has to be the longest side, and that is our c. So go ahead, push pause. When you're ready to check your answer, push play. Alright, so the hypotenuse would have to be the 25. Your a and your b then would be the other two sides. It doesn't matter which is which. So you would have x squared plus 6x, or plus 6 squared equals 25 squared. When we square them, we get 36 plus x squared equals 625. We need to subtract the 36 from both sides, which gives us 589. When we take the square root to undo the squared, we end up with a 24.27 feet. So our ladder is 24.27 feet off of the ground. For this question, we're going to find the area of the triangle. And there's our formula, 1/2 times base times height. Well, the base we already have, and that is the 30. Way up here at the top, there's the base of our triangle, but we are missing the height of our triangle. So we need to use Pythagorean theorem to figure that out. So the reason that we need that is that since we know it's an isosceles triangle with 18 and 18, we know that if we find the altitude of this, that these two segments will be the same size. Those are both 15 and 15. So now we really have a right triangle where we can use the Pythagorean theorem then to find the x value. And that would be our height here at the end. So go ahead and set that up and solve for x. When you are done, then I will walk you through finding the area. For your setup, you should have x squared plus 15 squared equals 18 squared, because 18 is our hypotenuse. So when we simplify both of those, we get x squared plus 225 equals 324. When we subtract 225 from both sides, we get x squared equals 99. When we take the square root of both sides, we end up with 9.95 feet. I then need to put this 9.95 into my height for my area of the triangle. And when I multiply 0.5 times 30 times 9.95, I end up with 149.25. For the next one, I would like you to try this. So draw your isosceles triangle. The base is 20 meters, so just like my 30. And the congruent sides and the sides are 26 meters. And I want you to find the area of the triangle. So go ahead, push pause, work it out, draw a picture, first of all, if you haven't drawn a picture yet. And then you can find the height and then plug that back in for the area. All right, so your missing height you should solve for should end up being 24 meters. Once you plug that in, you get 240 meters squared for your final area, and this is the work to show it. Here is the first part of the triangle. Then we know that the two pieces on the bottom are both 10. So I'm saying that my x value is the height of this triangle. So I have 10 squared plus x squared equals 26 squared. So once I solve this, you should get x equals 24. So once you multiply all your values together, you get 240 meters squared. A Pythagorean triple is a set of three positive integers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. This list right here is just a huge list of all the different possibilities. The main ones that you could possibly see are the ones that are in bold. So go ahead and put a star by each of those. Those are the most common ones you could possibly see. So some questions you're going to see, you're going to be given three numbers, and you have to determine if it's a Pythagorean triple. So basically, if you put it into the Pythagorean theorem formula, so ax squared, or a squared plus b squared equals c squared, and see, does it equal the c squared part? Are they actually equal on both sides? If they are, then they are a Pythagorean triple. Plus, they need to be just integers, so no decimals, no fractions. So just the integers. So go ahead and I'm going to work out the first ones, and then you can work out letter B and letter C choices. So first we're going to do 12 squared plus 16 squared. I get 144 plus 256. When I add those together, I get 400. Then I want to separate it, and now I want to do the 20 squared. 20 squared is 400. And I want to compare, so I can see, yes, that they are equal to each other. So that means that, yes, this is a Pythagorean triple, so this would be yes. So I would like you to now try letter B and letter C and answer yes or no based on if it's equal to the other side. So letter B, when you add the two numbers together, you get 2,704. On the right side, when you square 50, you end up with 2,500. Since these are not equal, this would be no, it is not a set that's a Pythagorean triple. For letter C, when you square the 32 and 60 and you combine them together, you get 4,624. When you square 68 squared, you end up with 4,624. Since these are equal, then we can say yes, that these are a set that's a Pythagorean triple. On this slide, there's not so much to write for yourself, but more to underline. So if you notice that these three different setups are to find out if we have an acute, an obtuse, or a right triangle. When we use the Pythagorean theorem, you're going to take your a squared plus b squared. You are going to still compare it to the c squared. So this is what you need to look for. If our c squared, if it's equal to the a squared plus b squared, then it is a right triangle. If the c squared is less than the a squared plus b squared, then it is an acute triangle. If c squared is greater than, it's going to be an obtuse triangle. So you might want to pay attention to the three ways that I wrote it, because usually we are going to have the a squared plus b squared first. So if the two smaller sides of your triangle squared and added together are more than the third side, so that means that the third side is smaller than a squared plus b squared, then it's an acute. If it's equal, we already know that's going to be a right triangle for a regular Pythagorean theorem. But if our a squared plus b squared is going to be less than the third side squared, then it's an obtuse triangle. So that would be the c squared is really greater than a squared plus b squared. So this is to find out if we have an acute, an obtuse, or a right triangle. So first we need to add or square the two smaller sides and add them together. So that would be our 6 squared plus 8 squared. This means we get 36 plus 64, and that equals 100. Next, I want to compare that then to the third side squared, so that would be 9 squared. which then is 81. So I can see that my a squared plus b squared is greater than the c squared, or to flip that around, I know that c squared is less than my a squared plus b squared. So because c squared is less than, that is making it an acute triangle. So I'd like you to work out the next two. So remember, if c squared is greater than the a squared plus b squared, it is an obtuse triangle. If c squared is equal to a squared plus b squared, it is a right triangle. So go ahead, push pause, work them out, and when you're ready to check your answer, you can push play. All right, so for number 2, when you square the 2 squared plus 4 squared, you get a 20. When you square the 5 squared, you get 25. And we know that the 20 squared is less than the c squared, so my 25. So my c squared is greater than the a squared plus b squared. Because we have a c squared that is greater than the a squared plus b squared, we have an obtuse triangle. For the last one, you have to figure out what the 3 square root 2 is, and that is really 4.243. The reason you have to do that is to make sure that you are squaring the two smaller sides to compare it against the third side. So my third side is the 3 square root 2, since that number is larger than the other ones. So we take 3 squared plus 3 squared, and we get 9 plus 9, so we get 18. When I square my 3 square root of 2, this is what I will get. So first off, I have to square both pieces, and then when I take the square root of 2 and I square it, those cancel, so I end up with just a 2. And when I get 9 times 2, I end up with my 18. So I also have 18 for the other side, so these are equal, so that means this is going to be a right triangle. These are 2 practice questions over the different topics we've talked about in this video. So the first one, if you have a diagonal, you're trying to find the diagonal of a square. If the side lengths of your square are 5 inches each, the first thing we need to do is draw a picture. So go ahead, draw a picture, put your measurements in there, and because this is a right triangle with a square, you can use Pythagorean theorem then to figure out your missing sides, since you already have 2 of them. So go ahead, push play or push pause, and then work out your answer. When you're ready to check your answer, go ahead, push play. All right, so this is what your picture should look like. So then we can take our 5 squared plus 5 squared equals x squared, because our hypotenuse is the part we are trying to find. When I simplify this, I get 25 plus 25. So that means I will have a 50 equals x squared. Remember, when we take the square root of the, the square root of the squared, that they're going to cancel each other out. So really we're just taking the square root of 50, and that will give us our x, which is 7.072. For the last one, I would like you to answer that one as well. So if you're given 2 sides in a triangle, so it's not the hypotenuse, but it's the 2 legs, so 4 and square root of 7, what would the third side need to be so that it would create a right triangle? So think of a right triangle needs to be equal to, so when we do our a squared plus b squared equals c squared, it needs to be equal. So go ahead and solve that for what the c value needs to be. So when we set it up, a squared plus b squared equals c squared. The 4 and the square root of 7 are my a's and b's. And we're using our Pythagorean theorem then to solve for the c. So 4 squared is 16. The square root of 7 squared, remember that the square root and the 2 cancel each other out, so we end up with just a 7. So then 16 plus 7 is 23. So when we take the square root of both sides to cancel out the squared, we end up with the square root of 23.